Hi, Suhu. So, given the option of doing bookwork and the video, I decided to do the video again because, there's some problems with your bookwork that I don't really understand. So, we're just going to go with the flow and go straight to the video. So, ready or not, here it comes. All right, welcome to chapter 7 of this year. That sounded weird, but welcome to chapter 7 on rational expressions, dividing, subtracting, and multiplying. So this should be fun. So let's get started. We're gonna start by me explaining about multiplying rational expressions. And what you see here is that I set up a problem, and basically it's multiplying with fractions, basically. So what you can see is that when you multiply a fraction, you don't need a common denominator. So you can just you can go across, like you see here, you can go across, multiply them, and you end up with your answer, which is 56x to the 7th, y to the 4th, over 8x, and y to the 3rd. Now, what you can do next is break it down, simplify it even more. So 56 divided by 8, you get 7. Then since it's multiplying, anytime you have similar variables and you're multiplying, you may cancel out. But any other time when it's either adding or subtracting, that is not possible. It must be multiplying in order for you to eliminate variables. So here you can see that we actually have we're multiplying it as similar exponents. So you can do 7 minus 1 because there's a visible 1 in front of the x right here. You get 7x, 7 minus 1 equals 6. And then you have 4 minus 3, which is 1. So you get your answer 7x6, y, final answer. Simple enough. Let us continue on to the next one. All right, so we're still multiplying, but the difference is that we have a more complex equations where you see we have 3x minus 3x squared, and on one, and maybe on the other, we have the numerator being x squared plus x minus 20. So in order for us to get situated, we must first simplify each equation to its simplest form. Now, what does that mean? Well, technically, for example, for x squared plus x minus 20, you want to factor that out. How would you factor? You would do completing the square. So you complete the square on it, you end up with x plus 5 in parentheses and x plus x minus 4 parentheses. Multiply it together, you get what you had before. Now, if you forgot what's completed in square like I did, it took a while to remember, but in short term, you must figure out two common factors, so it will give you negative 20. And when you multiply them, you must get a negative 20, but when they're added or subtracted, you must get the 1x, positive 1x. So make sure if you get confused, there you go, that's how you complete the square, people. Pretty easy. And your x squared just goes on both parentheses. Okay? Simple enough. Now, when you want to simplify your 3x minus 3x squared, you want to know, you first want to see what term can you take out of both of them. Now, you can see you could take out a 1, 3, so you combine the 3's to make it 1. And you see that you could take out 1x, so you take out 1x and you combine both of the x's from each number and you combine them into 1. So what you're left with is 3x parentheses 1 minus x. You do completing the square for the bottom to get the denominator, and then that cannot be factored or simplified in any way, so you leave it as it is. Now, since it's multiplying, again, you don't need a common denominator. You combine the two, you get 3x, parentheses, 1 minus x, and x plus 5, parentheses, x minus 4, parentheses, over x minus 1, and all that you can see. Now, the book, I have these examples from the book, so it has me break this down more to be -1 and x minus 1. Don't ask why, don't even comment why, just go with it. Now, what you can do here, remember what I said before? If you see similar terms and it's multiplying, you can cancel out. So I'm just gonna take a different color. And you have x plus 5 on both, so you can scribble. Well, that works too. You can take out 3x too, and you can take out an x minus 1 on both. You're left with nothing on as a denominator. You're left with only x minus 4 and -1 on top. And when you combine the two, you get -x plus 4. And that's how you multiply rational expressions. On to the next one. Now I'm gonna go a little out of order because for time's sake, and it's nighttime and my parents are asleep, so I don't want to wake them up. So for time's sake, I'm going to rush. Okay, so say I own a well, first let me explain. In class, we discussed what happens if you would own a place and yet people working for you, and one person is doing a fast job of creating something than the other. How is the time different if they work together? So here's an example. Say I own a fabulous rising bakery shop, but it only sells cookies because cakes and all the other stuff is overrated. But I like cakes, so that's why. Anyway, say I sell the best cookies ever in Redondo, and yeah, just say in Redondo. And I make great cookie cakes. Now, if you don't know what a cookie cake is, a cookie, it's huge, and it's in a form, and it's a cake batter, and it's with frosting, and it's just delicious. Oh my god, I really want one. Anyway, say I make them. Well, I have people working for me. My buddy, Bud, say he makes one of them in 10 hours. That's good and all, but if you have a lot of orders, that's going to take forever. But then I have my best buddy, Leslie. Now she makes one in 6 hours. Less than Bud, not Bob, Bud. And so, in my little manager mind, I'm thinking, well, what can I do so I can get faster cookies out the door? What happens if I would put them together? And my dog just walked in, so I'm just gonna buy. I had to take care of my dog, so sorry about that. Ugh, my hair looks like a mess. Anyway, let's get to work. That didn't work, but I'm gonna need my steady buddy. Pikachu dropped the present, so my bad. Anyway, Pikachu, where were we? Yes, we were discussing about cookie cakes. So now I'm thinking, so in my little manager mind, I'm thinking, how in the world can I make more? How could I have faster production to make more cookie cakes? And I have a bad idea. I wonder, if I put them together to work, how many hours would that take? Well, there's an equation for that. So, you already know. So, our x's represent the number of cookies. See? The x is, okay, embrace that. Let's say the number, oh my god. Okay, I get it. I'm pausing it. Sorry, Sue. Oh my god. Okay, I hate you. So you're going to pause. Okay, so this is gonna pause. So I'll be right back. Gotcha. Bye.